H2K Infosys provides world-class online IT training, staffing, and software testing solutions to customers worldwide. H2K Infosys supports 100% job-oriented training, hands-on project work, cloud test lab, resume preparation and review, mock interviews, robust syllabus. One-time pay, lifetime access to live classes and videos. H2K Infosys has won the trust of thousands of students worldwide. For free demo class, visit h2kinfosys.com.
Say Z, but that's fine. I want to store it the value in Z, so that way it is here. So before your operation, you need to have that. Moreover, what is the data type of your target? It must be this. See now, no error. Okay, see now, no error. Now print Z value. Okay, now we 120, no problem. Why it is retained? Because byte has range of -127 to +127. So this 120 is within the range, so it could store, no problem. But now see this. Would it? No. Reason being, what is the range for byte -128 to +127? What is the current value for integer x? 1200. Whether 1200 fit into byte? Tell me. No way.
No.
So now what will happen?
So
in this case, you cannot guarantee your original value is retained. Okay, it will show a value, but it is not your original value. So this is -8. How it is? On what base it is giving -80? 120, 1200. Okay, so normally this value is not original. So remember, whenever you are using typecasting, remember that your value may not be retained. Okay, mandatory. Mandatory, your value will be retained. Your value may not be retained. So it is a implication of that. So you need to be aware of that implication and then apply consciously. So don't blindly do typecasting. Only you need to read through, completely understand. Okay, if it is fine, if you lose a value also fine. That is how it is. Now, how it is generated 120 means actually it takes a cyclical notation. Okay, now observe this.
I have a question.
Let me complete this. Okay, I'll take 127, correct? Because 127. So our byte range is -128 to +127, no problem. Now observe this. We have this for our byte. No, byte cannot store +128, correct? Agree?
Yes, yes.
Now you see what is the value it is going to display. -128. How come? Actually, what happens is it will cycle the values, or we can say it recursively go with this range only. So it is crossed 127 because 128 is not there. It has picked this guy. Now, if I give 129, it will be -127. Why? After 128, next one is -127. So that way it do cyclical something. For that 1200 also, it given similarly, some value it is generated cyclically was 80. That's it. So whenever you are using typecasting, remember your original value may not be retained. Okay, that is the effect of typecasting. So you need to know the disadvantage of it, then only use it wisely. Okay, but do we get these scenarios? Yes, sometimes we get, but not always, rarely. Yeah, go ahead. Somebody was asking me a question.
How did you get a -80?
Okay, that's what I'm telling. Now up until 127, no problem. After 127 to 128, it is given -128, correct?
Yes.
If you see the cyclical. Similarly, it has applied all these 1200 times, and then that cyclical value generated for that 1200 was -80.
How about if you put 1300?
Same, different value. You don't get the same value because minus 80 plus 100, it will be minus 180. Observe. 20 because it actually crossed 127 something. So you cannot guarantee that same value will be there always. For example, 1200 we given, right? 1200 was 80 minus 80. Now you see it will be minus 90 or minus 70. See, minus 70. Okay. Now if I give 1220 minus 60. So it cyclically does the value. That means what? Your original value is not retained. Reason being, it is having a bigger value. This value cannot be fit into byte. So it will generate its value based on the size. So here it is minus 60. So is it matching to the original value? No. So that is the effect of typecasting. You need to know your value is not maintained. So you need to be careful while using it. Okay. And this is not automatic. This is manual. That means we are giving this to convert it. That is how it is. Okay. So not only for integer, we could do for floats also. See this here, float, for example. Okay, float. Let's say a1 equal to, okay, and no, sorry, double to float, double d1 equal to, okay, d it must be, and then I want to convert it into float. For example, float d2 equal to d1. Same, your d1 is a bigger size and d2 is smaller size. So what is my here float? Okay, now you print this guy, you may not get original value as is d2 d2. Let's see, you may not get original value. Okay, so this is given in E format, scientific format, guys. Okay, for example, if I increase by little more, completely different. See, so this is how it is. So even when you have a bigger to lower, so we cannot guarantee that it will retain the same. Okay, it will retain the same. So this is how it is. So but you need to use this consciously. Okay, that means you need to know what is the implications in case if you are using that. Okay, so this is called typecasting and type conversion. Conversion is automatic, you don't need to do because you are going from smaller to bigger, no problem at all, but only bigger to small when you go. So this is the problem. Okay, so that is called typecasting. Now Java keywords, what are keywords are, we know that they have predefined meaning in Java. For example, whatever you see, double, float, byte, all these are out, all these are actually predefined meaning in Java. So those are called keywords. So if you see, all these are here, not out. Actually, out is a method under this class. So that's not. So this is. So if you see, all these are the keywords. Why we can't use them as a variable or as a method is normally Java have a predefined meaning for that. So we should not use them as a variable or a method. How to identify easily is our Eclipse actually makes them popular. See this, all these are actually keywords. So we must not use them as a variable or a method or even a class also. Okay, so let's not use that. So that way what happened, Java also don't confuse. Okay, so that is called keywords or reserved words, what we have in the Java. That is there for every program, not only Java guys, for every program. Now interesting thing, before that let's see a few more. What it is here itself I will take about the math class. I told you there is a class called math, right? So using math. So there is a class in Java where mathematical operations are performed. We don't have any operators in Java which does mathematical operations except multiplication, addition, subtraction, division, and remainder. All rest are either comparative or logical or assignment operators normally. But arithmetic operators, what we have is this. But not always we do only this. For example, we want to find something like power 5 power 5 or 3 power 5 or 10 power 5, something like that. So how do we do? These kind of mathematical operations are available in Java in a class called math. For example, I want to find a pi value. See this. So this math class has all those. If you want to really know what this class contains and all, you can go and search Java 8 API documentation, okay, or Java latest version also you can go, no problem. So here you go for java.math. See this? No, java.math is a different package, lang, okay, lang, and then here you might see a class called math. Where are you? Yum. Yeah, here it is. See this? Yeah, see this? This is math class. So this contains different methods and variables which we could use them also. What is the field cities is pi value, exponential value. Pi value we know it is 3.142999 or 277 something, right? That is fixed here. So that you can use it as a pi. So whenever you want to use call a pi value, for example, you want to calculate a area of a circle. What is the area of circle? We know pi r square, pi into radius, right? So that way. Similarly, if you want absolute value, you want to convert your negative value into positive value, so it is called absolute value, so ABS. Similarly, you want to do tan, sine, all that, see, sine value, tan value, it is trigonometry, if you see, okay, ceiling, and then we also have cos, trigonometry, and then exponential, see, 2 power 5, 5 power 10, all that you can do with this method. What this class basically contains is this class contains methods which are useful for mathematical operations like logarithmic value, okay, exponential value. So all those types are here. Normally what we do is actually very few we do, okay, we could use them anything, no problem. Normally what we do is this one, pi value, and then ABS. If you want to convert a negative value into positive value, ABS method we use. See, and one more thing what we normally use is exponential, EXP, okay. So exponential, which is raised to the power, see this here, number e raised to the power of double value, okay. So exponential, and then what we normally use is logarithmic value. See this, logarithmic value, log, by default logarithmic value means base 2. This is for log 10, log base 10, okay, like that, okay. And then max minimum also we could use in a 2 numbers, okay, that is fine. We don't use that because we have another, or we can do our own programs there, not a problem. And then random number, see, you could use, and this is actually a power, exponential is there, and even power, see, power also raised, so 2 power 5 we can do here. This one is actually exp is exponential, so power is the one which we normally use as well, okay. So that way, and then square root, see this here, if you want to find the square root of a number, SQRT, square root. So all the mathematical calculations are here, sine value, cos value, tan value, okay, trigonometry. So all that will be here. So normally we use only these, okay. So let's see that. Now why I'm doing it is, for few of the exercises we require power. That means I need to raise to the power of n, for example, in this program. So for that, we will see what are the common mathematical operations we see is how to use that. So as I said, there is a class called math, which is in java.lang package. Okay, so math.py. See, math dot itself, it will give you all the methods which are available. For example, I want a pi value. Pi value is a variable. Okay, that's it. For example, if you want to print that guy directly, let us see what this guy contains. See, math.py. Pi value is usually 3.1415 something. See, so where did we get that value? It is already there with this particular class. How we are using is class name dot that variable or method name. This is how it is. For example, you want to convert a value as absolute value. See this here, int I equal to minus 334. Okay, now if I want to convert this into absolute value, that means math dot abs of I. Now you see minus will go and it will return 334. Absolute value converts your negative value into positive value. Simple. Similarly, power. Okay, for example, I want to calculate this result equal to 2 power 10. Okay, 2 power 10. POW math.pow, sorry, math.pow. Okay, 2 power 10. So 2 raised to the power 10. Simple. That's it. So if you see here, math. So normally, why it is throwing as error is this power takes double as parameter. So return value also it expects double. So that is the reason you are given return value. So it is asking us either you cast it or you convert this into double. So let's convert into double, no problem. We can cast also, no problem. But now you print the value for R. This is ABS of I, and this one is 2 raised to power 10. I will give like this. Okay, so now R. Okay, now you see 1024, correct. Okay, simple. This way we can get. So this math class has all these methods or values like pi. We can directly use them in our program. So how to call? Simple. Math class name dot method name. Okay, it is a class, so that is the reason we are calling it with class name dot method name. You cannot directly call abs here, we can do, but we can directly call pi also without math dot. Okay, so that we will see later. We need to understand what is the package, what is the class, so that comes only once after we complete the basic things. Okay,
I question.
yes, we cannot do foreign heat and conversion. Reason being, this math does not have any generic formulas. Okay, so this has only mathematical specific operations only. So converting in Fahrenheit into centigrade, there is no formula in this mathematical, our math class. Okay, so that we need to do as a program. But exponentials, if we have, yes, we can do, no problem. Okay, so that is how it used to be with the math. So with this, what we need to do, there are two exercises. What we need to do, this one. What it is, can you guys apply this formula? What it is, P principal equal to, amount equal to principal into 1 plus power R whole power T. This is the compound interest formula. Okay, principal equal, amount equal to principal into 1 plus R. R is rate of interest, power T. Similarly, formula for EMI. So for example, if you have taken, let's say $100,000 as EMI for 10 years. So what would be your EMI will be calculated here. P 100,000 into rate of interest, for example, 2%, let us say. 2% means 2 divided by 100. Always remember, R comes as a percentage. Even here also, guys, whenever you say 2%, 2 divided by 100 here also. Okay, that you need to do. However, in case of EMI calculation, you need to divide it further rate with 12. See this. If your rate of interest is, for example, 10.5, your R value will be 10.5 divided by by 100, it will be 0.008 per month. Okay, so per month, that is how we need to take like this. Okay, so and then 1 plus r rate of interest whole power n divided by 1 plus r power n minus 1. So these two are the formula. I will send you guys mail also today. Okay, but I am pinging in the chat as well. So these are the one we need to do. Okay, that formula did not come. I think it is a image. Let me try if I can send. No, I'm unable to send the image. Ignore it. I will send the mail. Okay, so these two are for the exercise for tomorrow. That's it. Okay, any questions, guys? We move before we go to the next topic.
Yeah, why did you double in here? Because we're
Okay,
expecting a decimal.
reason being, see this here. What is that? We taken POW, correct? MNOP. Yeah, here you go. POW. What is the type of inputs it is taking? Parameters? Double type. What is the return value?
Double.
That is the reason. Because it returns double value, so the variable whatever you are capturing also must be double. Otherwise, if you take integer here, you need to typecast it. Correct? Because double is having more size. You are taking it as an integer. So can it fit in smaller size? No, we need to typecast it, right? So that is the reason. Okay, so if you take the same data type, whatever it is returning, no problem. It automatically can easily do that. So no typecasting or no type conversion is required in this case. Simple.
But the value has to end with the D, right, Srinivas?
No, see, that is only when we are assigning a value. Whenever it is taking value during the operation, it doesn't.
Oh.
Only when we are assigning a value for the representational purpose only we give D. D is only for representational purpose. Remember, it won't carry for your value. Okay.
Okay.
Yeah. Okay. Now, one more thing is, while you are doing this exercise, remember you need to apply this one also. Read your value from the keyboard like this. So read principal value, read rate of interest, okay, and then generate a number of years also. Read the time and then generate the actual amount. Similarly, for EMI also, read principal, read rate of interest, read number of months. Remember, for EMI, it will be number of months, not years. Whatever be the N value you are taking, this is number of months. See, okay, not year, number of months. So how many months, and then it will generate the EMI for you. Okay, clear?
Srinivas, can you go back to the Eclipse? So that ABS in the other program? Yeah, so the ABS, can you just explain?
Absolute value. What it does is it will convert a negative value into positive value. So your minus is taken away.
Okay.
Okay, that's it, guys. Okay, let's go to the next topic, which is control flow statements. What these are, so far, whatever be the programs we are doing, very fine. We simply have any of the calculations now we do very easily, fine. But not always we have these kind of programs. Reason being, lot of our application behavior requires decision making. Decision making means, for example, we are developing an application for student marks uh, application where we need to enter the student marks, we need to calculate the total, we need to find out who is topper or blah 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 this. Now calculation we can easily do in because we know operators and we know mathematical operations also, for example. However, sometimes we may have to make the decision. What it is if a particular student marks is less than the expected total marks, he must be failed, for example. Or if a particular student marks is less than the student expected marks, he must be graded with some. first class, second class, or third class, or maybe distinction, something like that, right? How do we do? Those kind of scenarios requires a decision making, which is a conditional flow. That means based on a certain condition you need to do. So if your total marks is less than 300, for example, then we could say he is a third class or low grade. Okay, but if your total marks greater than 300 but less than 400, then we say second grade. Or if your total marks greater than 400 and it is a first grade, for example. So how do we do? So these are all decision making based on a condition. So not always we have programs like this, and in our application also, no. Application actually based on a lot of logic behind it, right? So whenever we want to design something, we need to have a conditional flow. Conditional flow statements, what they help is based on certain condition, you can easily control your flow. Okay, so one such statement which is very useful in Java, and it is also in many of the all the other programming languages also have these statements. Not only in Java, whatever we learned so far in Java, it is there in every programming language, guys. Maybe the way we use or the syntax may be different, but the logic, everything is same. Okay, now let's see what is this control flow. So as the name itself says, control flow, it is a conditional flow, will be executed based on certain condition. Okay, so that is what. Now first one is if statement. If else statements, or if statements normally people call. So this is a very basic conditional flow statement in Java, where based on certain condition you can execute certain block of statements, otherwise you can execute certain block of statements. And this if conditions or if else condition have four forms in it. One is, first one, simple if statement, we also call it as simple if. And then you have if else statement, and then we have if else if ladder, and then we have nested if. Nested means one within another. Okay, so these are the first basic flow or conditional flow statements we have in Java. Okay, very simple. First statement, let us see how if statement works. Normally in our programs, the execution will be top to bottom, right? In this particular method, if you take, the execution is top to bottom. Okay, we are not disturbing the flow. So as it is, it comes, it go. However, when in case of conditional flow, based on a condition, you can actually drive your control flow different statements also. Okay, that is a conditional flow. Let's see the first if or simple if statement. In this case, what happens is you have a condition. Based on condition, you can execute certain set of statements. These statements will be executed only when this condition becomes true. If your condition is false, it will go to the next statement in the queue. That's it. So your set of statements would not be executed. These are called conditional flow. For example, I want to check whether a particular variable is greater than 0 or not. Simple. Okay, so let me create one more class under this guy, one more package under this guy. I will reorganize my packages today, guys. So while you get it, you may see different package structure. So I call conditional statements. Conditional statements. It's a bigger one. Not do that. STMTS. Okay, conditional statements. Okay, that's it. Or control flow also we can call. Let me rename. How to rename is go to here, refactor, rename. So I call control flow only. Let it be. Okay, that's it. Now first one is if statements, right? So if statement demo, I call this if statements demo. First one is simple if. Okay, now how it is as you see, this needs a conditional statement. First one is, let me take a variable, for example, int a equal to 34. Now I want to check whether a greater than 0. That means whether a is positive number or not. So this if condition, how does it works is, this is the syntax. If